The next example is finding the solution of this differential equation. Now x0 is equal to 1. So you got to check every time they asking you to find the solution around x0. You got to check whether your x0 is the ordinary or singular point. So I just starting with checking whether x equal to 1 is an ordinary point or singular point by rearrange the differential equation in such a way that we get px and qx. And then now our px is minus 2 divided by 4 minus x squared, and qx is 12 minus 4 divided by 4 minus x squared. So from this you would know that we have two singular points, which is x equal to 2 and minus 2. Now, the problem statement asking us to find the solution while x equal to 1. Now, our 1 is the ordinary or singular point. It's an ordinary point. So, we can assume the solution in this way. But from this, it's hard to solve for the answer of this differential equation if you still keeping the term x minus 1. So I just assume that x minus 1 is equal to t. In order to make the term inside here become only one parameter. So this is what another assumption that I put there, and then so I would say that my answer is y is equal to summation n equal to 0 to infinity of an times t to the power n. So that means I'm changing x to t. That every term which has x inside our differential equation, I've got to replace it with t. Okay, so that's why I write down here that my x is equal to t plus 1. Now, I do rearrange the differential equation again in such a way that I get the terms of t. And then I have this differential equation, and then I just replace all my y terms, which is a function of t, into my differential equation. So I got to do first and second derivative of y by t, and here is the result of doing the derivative of y. And then I just put all terms into my differential equation, so we get this equation. And then I do distribute each term there, right here, here, and here. So the first term is 3 times summation of an times n minus 1 times t to the power of n minus 2. And the second term is minus 2t. This t just combined with t to the power of n minus 2. So I would get n minus 2 plus 1, which is n minus 1. And the last term I have t squared. So it's combined with t to the power n minus 2, so I would get t to the power n. Okay. And now my second term, I do distribute to t and then put it with this one. I have t here and t to the power of n minus 1 there, so I would get t to the power n. Okay. But this term, I still get t to the power of n minus 1. And the last term, I would get 12 times summation of an t to the power n. Now, just take a look at which term which has the same power, put them together. This term and this term, I put them together because I have t to the power of n minus 1. And this term, it have t to the power n. I put them together. So I would get here, the first term, you cannot combine them together with anybody. The second term, you combine the term which has t to the power of n minus 1 together. And the third term, you combine the term of t to the power n together. Okay, so the next step is like, the thing is just that I do is just take a look at the terms here. You have an and an, and you have n here and n there, so you take it out. You would get an and n here, and inside you would get n minus 1 plus 1, which is equal to n. And this one, you have an, all three terms you have an, you take an out. The first term you get n times n minus 1. The second term you got plus 2n, and the third term you got 12. Very getting close. Okay. And then, because this one you got n times n is n squared. You got n squared there. And this term you got n squared minus n plus 2n minus 12, which is equal to n squared plus n minus 2. You just make it simple as you can see. And then you want to combine all three terms together. What should you do? You do the tip of index, right? The tip of index, you want to make the power of t to be what? n minus 1 or n minus 2. N minus 2. So if you want to make it to be n minus 2, so second term you got to replace it with n minus 1, and the third term you got to replace n with n minus 2, right? Then we do the tip of summation. Here we go. The first term you don't need to do anything because you already get the term of t to the power of n minus 2. The second and the third term, the second term you replace n with n minus 1, and the third term you replace n with n minus 2. So every n in the second term you put it with n minus 1, and the third term, every term in the third term you replace n with n minus 2. And then you do rearrange it again. But if you take a look at it, the first term starting from n equal to 0, the second term starting from n equal to 1, and the third term starting from n equal to 2. You cannot combine them together unless you put n starting from the same number, which is 2. So this one, you put n equal to 0 and 1 there. You will get 0 and 0, and then the summation starting from 2. And the second term, you put n equal to 1 there, and you starting from n equal to 2. The third term is already okay. From that, now you have the term which is starting from n equal to 2 the same, and the power of t is the same, which is t to the power of n minus 2. So you can combine these three terms together. When you combine these three terms together, you would get there. This one, you would get the relationship between an and n, and some other n. But this relationship got start from n greater, equal or greater than 2. And then we just assume the number. Put n is equal to 2 in order to find the root of it. Like I said, when you plug n is equal to 2, you get the value of a2. a2 is a function of a1 and a0. You put n is equal to 3, a3 is a function of a2 and a1, but a2 itself is a function of a1 and a0. You just replace the number in there, then you would get a3 is a function of a1 and a0. But this one, as you see, is not a reason, so that's fine. Now, to me, because I already know that my a2, a3 is a function of a0 and a1, and it's not a reason, so we don't need to go further. I mean, we don't need to replace with a4, a5. So I'm going to do the answer saying that from our assumption, we know that our y is equal to summation of an times x minus 1 to the power n, which is equal to a0 plus a1 times x to the minus 1 plus a2 times x to the minus 1 to the power 2, and so on. And then you plug the value of a1, a2, and a3 there. a1, a2, you don't know the value, put it there as a constant. But a2 and a3, they all are the function of a0 and a1. You just write the number down. And that's it. And then you just combine a1 with a1, a2 with a2, something like that. And then you plug the boundary condition in there. It's saying that at x equal to 1, your y is equal to minus 7. So if you can see that every x there, you have x minus 1. When you put x equal to 1 there, every term, the rest of the term here is equal to 0. So from that, you would say that, okay, your a0 is equal to minus 7. And for your second boundary, saying that the first derivative of y at x equal to 1 is equal to 3. So you do the first derivative of your solution, you would get 0 plus a1 plus 2 times x minus 1 times this constant. So if you have the term of x minus 1 to the power 3, when you do differential of it, you would have the term of x minus 1 to the power whatever there. But you would have this term all the time. So when you plug the boundary value in there, you would see that this term would be equal to 0, and the rest of the term would be equal to 0 because they have the term of x minus 1 there all the time. So you would get a1 is equal to 3. Right? You would get a1 is equal to 3 by this boundary condition. So now you know the value of a0 and a1. You can find the value of a2, a3, a4, a5. And then you would know that if you replace the number in there, you would see that a4 is equal to 0 and a5 is equal to 0 if you plug the number in there. Because the function that you have is already there. And that makes the rest of a is equal to 0. Because you know that a5 is a function of a4 and a3. So a6 is a function of a4 and a5. Because a4 0, a5 0. So a6 0. a7 is a function of a5 and a6. a6 is a function of a7 is a function of a5 and a6. a5 and a6 is equal to 0. So now a from 6 to infinity would be equal to 0. So you have only a1 until a3. Oh, a0 until a3. So now your answer is y is equal to a0 plus a1 times x minus 1 plus a2 times x minus 1 to the power 2 plus a3 times x minus 1 to the power 3. The rest of the terms are 0. And then you plug the value in there, you know the value of a0, a1, a2, and a3. And that would be the answer. The question asking you, what would be the value of y at x equal to 0? What you can do, just plug the value in there. You would know that at x equal to 0, y is equal to 0.